and I think I'm getting pretty close to finalizing the fuel system. I want to test some of my theories and make sure that the system works as I expected. I'm basically creating a prototype Gen 3 mini saber to see if the fuel system will work on the final lightsaber. And there we go. We have a mini saber flame.
Hey guys, welcome back to another lightsaber update. I've got some exciting parts to show you today, and we're going to start manufacturing the fuel system for our lightsaber and potentially even do some testing. Let's get to it. Alright, so the first super exciting thing that I've just received and we're going to put together is going to be our fuel tank. This right here is one of the parts that I'm really excited about. This is actually a metal 3D printed fuel tank. It's made out of aluminum, it's completely hollow, and it's got a really unique shape that is going to make sure we can get the maximum volume in the smallest possible amount of space. It actually stores about 70 milliliters or about 43 grams of butane, and because of the unique geometry, basically the only way to manufacture something like this was actually 3D printing. Basically on the side right here, I've gone ahead and tapped and threaded in our butane fill port. This is how we're going to refill the fuel tank. Basically you hold the lightsaber at an angle and you use your regular butane or your triple mix butane to refill the lightsaber. And then up here we have a threaded connection for our regulator, as well as some unique geometry to make clearance for the regulator and our oxygen system. And then this side is actually raised a little bit to maximize our volume. On the side here, we actually have 6 of these slot cutouts, which I've actually polished to be perfectly smooth, that are actually going to hold our heat pipes in order to make really good thermal contact and be able to transfer heat into the butane to maintain pressure. There's also 3 ridges going all the way around for us to be able to use our hose clamps to hold the heat pipes in place and make sure we have a lot of clamping pressure and really good thermal conductivity. And then there's also a cutout over here for the rack and pinion that is going to interface with our regulator to make sure that it can slide up and down and have proper clearance, not hitting the fuel tank. The use of 3D printing enables us to have this really unique geometry which maximizes the volume of our fuel tank, allows good thermal conductivity, and minimizes wasted space in the lightsaber, making everything smaller and run way better. Alright, let's put it together. So I've got a regulator over here, and that's just going to have a face seal against that thread there. So this actually threads onto here, and you can see the geometry goes all the way around the regulator, making it not only easier to fill, but also giving us that little bit of extra volume, making the whole thing smaller. And then once the regulator is on, we can actually put our rack in place, which is going to allow us to open and close the regulator using a thumb slide. Okay, so with our regulator installed, we can have our rack, and we can see how that rack is going to interface with this gear to open and close the regulator. All right, technically the fuel tank is fully assembled now. We have our butane fill port on one side and our pressure regulator on the other, allowing us to turn up and down the amount of pressure that the lightsaber is going to see. But before we can actually fill this and make sure that there's no leaks, there is a very important safety feature that's part of the lightsaber we need to talk about next. So a really important safety component of the lightsaber is our flashback arrestor. What this component does is make sure that if something goes wrong, we cannot ignite the fuel or the oxygen inside of our tanks. It basically prevents backflow of the oxygen going into the fuel tank or vice versa, and it stops the flame from propagating into there if that does happen. One of these is absolutely critical on cutting torches that mix the fuel and the oxygen before igniting it. While our torch does not mix our fuel and our oxygen until they're both leaving the nozzle, it's a little bit safer, but there is still a possibility of something bad happening. For example, if our gasket was to blow out or our nozzles get clogged, there is a potential of having fuel or oxygen mix somewhere inside of the lightsaber. So we need to size one of these down to fit into our lightsaber handle. Typically, these are made to handle a lot of flow at a very low pressure. Since our lightsaber runs at a higher pressure and doesn't need quite as much flow, we should be able to make something significantly smaller. But first, we need to figure out how it works. Over the last couple of years of making lightsabers, we've been sizing down our flashback arrestor smaller and smaller each single year. Going from the regular flashback arrestor you'd see on a regulator, to using a flashback arrestor you'd see on a cutting torch, and to machining that all the way down to just the bare minimum components. But this is still not small enough. But in order to make something smaller, we need to first understand how it works. So let's take one apart and figure that out. The first important thing that you see is just a regular mesh filter on the back. This makes sure that if you have any kind of debris in your fuel or when you're connecting and disconnecting your parts, that debris doesn't make it into the check valve and clog up your flashback arrestor. Taking this apart further, can I even take this apart further? Taking this apart further, we see a little spring with our check valve. So this has an O-ring gasket, a really unique shape to allow it to actuate at a really low pressure. That way you have a lot of surface area and a very low pressure fuel can still fully open this valve. You see the check valve sits in there and opens and closes to let fuel in if the pressure is right. This check valve is very important because if somehow the oxygen finds its way somehow into the fuel line, what will happen is this check valve will close and prevent the oxygen from filling the fuel tank. and creating a combustible mixture that could explode. That check valve acts like backflow prevention, which ensures that the fuel stays in the fuel tank and the oxygen stays in the oxygen tank no matter what happens. There's going to be no explosive mixtures. But what happens if it mixes in the hose and ignites in the hose? Well, for something like the oxygen, that could also be really dangerous because the fuel tank itself could be the fuel for liquid oxygen. So to prevent that combustion from going any further, we have this piece here. This is our flame arrestor, and this is a really simple piece. This is actually a sintered stainless filter. This is a mesh of really fine particles that have been sintered together, kind of like a sponge. So fuel and oxygen can pass straight through this mesh with very little restriction. If there's a flame on the outside of this mesh, the mesh will actually pull all the heat away from the flame, because it's pretty thermally conductive, and that will ensure that the flame cannot reignite on the inside of your fuel tank. So overall, the flashback arrestor is a pretty simple component, but it's very important. So how do we make this smaller? Well, the first thing I came across was actually these tiny little duckbill valves, which can be customized to include a mesh filter on the inlet and a sintered filter on the outlet. This is a duckbill check valve, which basically uses a gasket to open and close and allow fuel to only go one direction inside of this valve. And the sintered mesh in the front here works exactly the same as our flame arrestor. As you can see, this check valve is absolutely tiny, but will it actually work as a flashback arrestor? Let's find out.
It's going. So I'm adding oxygen. The oxygen catches and starts burning right into the tube. You can see there is a tiny little blue speck. Goes all the way back. That is so fast. Oh, I never realized. What is this recording at?
1,000.
1,000 frames per second? And this is where it starts accelerating. 1, 2, 3, 4. So in 4 shots, it covers a meter of tubing. But you can see there's fuel and it's gone. And then there's no flashback in the lens.
All right, so after doing our high-speed testing of our custom check valve flashback arrestor, it works surprisingly well and stopped all the flashbacks dead in its tracks. However, after doing flow testing on our check valve here, I found that although the component itself is tiny, the flow through this valve is also insufficient for our pressure and our flow rate requirements on the nozzle we're using for the Lightsaber. So we're gonna need something a little more custom than this. Here's what I've come up with. This is a spring-loaded ball check valve, and although it's a similar size to our dark bill check valve, this can handle significantly more flow. Unfortunately, this does not have the sintered mesh filter like the previous one did, so this will be completely useless to stop a flame. So we'll have to modify it and add one in. I went ahead and picked up some of these. These are sintered disc filters, which should work exactly like the sintered mesh inside of our flashback arrestor. The goal is now to take apart our check valve and get one of these installed on the inside of it, and then put a custom fitting on the end to be able to thread it on just like our previous flashback arrestor. This is what our final part looks like. We have a male threaded connection on one end that screws directly onto our fuel regulator, and you can see the press fit sintered mesh filter on the other side. Last thing to do is press fit another fitting into this end to make sure that that can screw onto our flow regulator, and we should be ready to test the fuel system. All right, now that we've turned our check valve into a custom flashback arrestor, let's test this one to see if it'll stop a flashback. Now that we know our custom flashback arrestor works, I've mounted it onto our fuel tank, and this makes up our final fuel system. It's super compact, but does it work? I still have not tested this aluminum fuel tank to see if it holds pressure, so let's do that next. Oh, it gets cold right away. It doesn't smell like butane, so that's a good sign. And you can hear there is liquid butane in there. First thing I'm gonna do is actually just light around it to see if we have any leaks. This is good to check before you light the main flame. All right, we have no leaks because the whole thing hasn't caught on fire and exploded. Let's see if this thing will work. And there we go. That's a beautiful flame, all coming from our tiny little custom metal 3D printed fuel tank and our flashback arrestor. All right, I guess the next thing that's left is to throw the nozzle on here and run some thermal tests to see how cold this gets. Ooh, already, this is, here, Matthew, feel this.
Oh, jeez.
Yeah, so that's why it needs to be metal. This fuel tank gets really cold really fast. So let's mount the nozzle onto here, power it up, and you can see the thermal footage. Here you can see me lighting up our lightsaber nozzle with our custom fuel tank and flashback arrestor. Once I get the flame adjusted, you can see just how rapidly the nozzle heats up and the temperature of the fuel tank drops. Here you can see how the nozzle temperature rises to over 150 degrees Celsius and the temperature of the fuel tank drops below 6 degrees Celsius. And there you have it, our completed lightsaber fuel system. Next up is going to be final assembly, mounting the vaporizer, the heat pipes, and running our thermal analysis to make sure that we hit equilibrium. Basically, the amount of heat we're pulling from the flame is sufficient for heating up our butane and maintaining pressure. Thank you for supporting and watching the lightsaber update videos. Make sure to check out our Discord to continue the discussion, and I'll see you in the next one.